Comet C/2025 R2, SWAN, a cosmic visitor on a long journey. Imagine the journey from New York to Los Angeles as a metaphor for the path of Comet C/2025 R2, SWAN, as it travels through our solar system. On this scale, the comet's closest approach to Earth would be about 170 miles from New York City, placing it near Harrisburg, Pennsylvania. That's the spot on our U.S. roadmap where you could mark the comet's nearest point to our planet. While this visualization helps us grasp the relative closeness, the reality of space distances is far more vast. In the cosmos, the comet will remain millions of kilometers away, traveling through the solar system as it has for millennia. On October 19, 2025, Comet SWAN will pass 39 million kilometers, 24 million miles, from Earth. This distance is more than 100 times the distance to the Moon, emphasizing that although it may appear close in astronomical terms, it is safely distant. Even for the keenest observers with powerful telescopes, the comet's approach will be an opportunity to witness a celestial phenomenon, not a threat to our planet. A glimpse at meteors, cosmic dust in motion. While Comet SWAN itself poses no danger, Earth is expected to pass through part of its orbital debris trail around October 5, 2025, when meteoroids, the tiny bits of dust and rock shed by the comet, enter our atmosphere. They burn up, creating the familiar streaks of light known as meteors. These celestial shooting stars are safe to observe and can sometimes produce a brief increase in meteor activity, offering a stunning natural light show for skywatchers. Historically, meteor showers have been linked to comets many times. The Perseids, for example, originate from Comet Swift-Tuttle, while the Leonids come from Comet Tempel-Tuttle. Such events remind us that comets are not just fleeting visitors. They leave trails of material that can interact with Earth years, decades, or even centuries later. Observing these showers is a way to connect with the ancient paths of these icy travelers across the solar system. What makes Comet SWAN special? Comet SWAN has intrigued astronomers for several reasons, combining elements of rarity, unexpected behavior, and visual spectacle. 1. Unexpected brightness. One of the first surprises for scientists was how bright the comet appeared. Normally, comets are small, icy bodies that may only become visible as faint points of light through telescopes. SWAN, however, appeared far brighter than anticipated, catching the attention of astronomers and skywatchers alike. Its brightness was first noted in solar imagery as early as August 2025, and photographs revealed a tail stretching impressively across the sky. 2. Late discovery. Another remarkable aspect is the timing of its discovery. Comet SWAN was first detected just one day before perihelion, the point at which it comes closest to the Sun. This is highly unusual for comets of such magnitude, which are often spotted weeks or even months in advance. The late discovery has added a layer of intrigue and urgency for astronomers who are eager to capture as much data as possible during its brief visibility window. 3. Spectacular tail. The comet's tail is a signature feature that makes it visually striking, stretching up to 5 times the apparent width of the full moon. The tail is formed from gas and dust being released from the comet's nucleus as it is heated by sun solar radiation pushes this material away from the comet, forming a luminous trail that can extend millions of kilometers into space. Observations of this tail not only provide a breathtaking visual, but also give scientists insights into the comet's composition and activity. 4. Uncertain orbit. Perhaps the most mysterious aspect of Comet SWAN is its orbit, which remains poorly constrained. Estimates of its orbital period range from 1,400 years to possibly 22,000 years, meaning this comet could be either a relatively rare visitor or a once-in-many-millennia traveler through the inner solar system. The uncertainty arises because the comet was discovered late, limiting the time available for precise tracking. Future observations will help refine these calculations and may reveal whether this is a returning comet or a visitor making its first known trip close to the Sun. What scientists think Comet SWAN is made of. Comets like SWAN are often described as dirty snowballs, made primarily of ice, dust, and rocky material. The icy components include water, carbon dioxide, methane, and ammonia, while dust rings are composed of minerals and compounds. These materials have remained largely unchanged since the formation of the solar system over 4.5 billion years ago. Studying them provides astronomers with a window into the conditions of the early solar system and clues about how planets, including Earth, formed. The comet's nucleus, or solid core, is typically only a few kilometers across, but it carries enough ice and dust to create a coma and an impressive tail when heated by the sun gas. Escaping from the nucleus drags dust particles with it, creating a glowing cloud that can be seen from Earth. Why the comet glows? The glowing appearance of Comet SWAN is not magic. It's the result of physical processes interacting with sunlight. There are two main contributors to the glow. 1. Reflection of sunlight. Dust particles in the comet's coma and tail reflect sunlight, which is why the comet can appear bright even from millions of kilometers away. 2. Fluorescence of gas. Certain gases, like carbon monoxide or cyanide, absorb ultraviolet light from the sun and re-emit it as visible light, causing the comet to appear greenish or bluish in photographs. This is why some comet tails seem to glow with colors that look almost otherworldly. In short, the brightness is entirely natural, a combination of reflected and emitted light from the comet's icy and dusty materials. Separating fact, despite SWAN's unusual appearance and late discovery, it is essential to separate fact from fiction. Social media and sensational sources have suggested that Comet SWAN could be a machine or possess an armored hull. These claims are entirely unsupported by evidence. Observations from professional and amateur astronomers confirm that SWAN is a natural comet, a body of ice, dust, and gas following the gravitational rules of the solar system. Its brightness, tail, and uncertain orbit are scientifically fascinating without invoking science fiction. The myth that comets are alien craft or threats is centuries old, stemming from human attempts to explain the unpredictable appearance of comets. Modern astronomy has debunked these myths. Comets are simply ancient travelers of the solar system, offering insights into planetary formation and a chance to witness the dynamic processes of our cosmic neighborhood. Observing the comet safely. For those hoping to observe Comet SWAN, it will be visible with binoculars or small telescopes, and in favorable conditions, parts of its tail may even be glimpsed with the naked eye. Observers should look away from city lights and toward a clear horizon. As with all astronomical phenomena, patience and proper planning can make the viewing experience unforgettable. The comet will not pass close enough to affect Earth physically, but it can spark curiosity and inspire a deeper appreciation for our cosmic surroundings. A cosmic road trip. Returning to our U.S. road map analogy, if New York City represents the start of the journey and Los Angeles the destination, Harrisburg, Pennsylvania marks the comet's closest approach. This analogy helps us visualize its proximity in relatable terms. While the actual distance is millions of kilometers, imagining it on a familiar map emphasizes how close the comet will come relative to its immense journey through the solar system. From its distant orbit in the outer solar system to its fleeting visibility near Earth, Comet SWAN is a traveler on an ancient and ongoing journey, reminding us of the vastness and beauty of space. The scientific value of comets. Beyond their visual appeal, comets like SWAN provide valuable scientific insights. Studying the gases and dust in a comet's coma and tail can reveal information about the early solar system, the composition of primordial materials, and the processes that shape planets and moons. Missions like ESA's Rosetta, which studied Comet 67P/Churyumov-Gerasimenko, have shown how comets can teach us about water, organic molecules, and the building blocks of life. Observations of SWAN will contribute to this body of knowledge, helping astronomers understand how such icy wanderers behave during their solar encounters. Looking ahead, Comet SWAN's rare orbital path means it may not return for thousands of years, making this event a unique opportunity for astronomers, students, and amateur skywatchers alike. Its appearance is a reminder that even in our modern, technology-driven world, the sky still holds mysteries and wonders that can inspire curiosity, scientific inquiry, and a sense of cosmic perspective. This is science. Comet SWAN explained. To make things crystal clear, here's a quick comparison separating common myth from what scientists actually know about Comet SWAN. Myth: Comet SWAN is a machine or alien spacecraft. Science: observations confirm it is a natural comet made of ice, dust, and rock, following a gravitational orbit around the sun. Myth: the comet is dangerous and could collide with Earth. Science: its closest approach will be 39 million kilometers, 24 million miles, far beyond any threat, over 100 times the distance to the moon. Myth: the comet glows because it is powered or artificial. Science: the glow comes from sunlight reflecting off dust particles and fluorescence of gases like carbon monoxide, which naturally emit visible light when excited by the sun's energy. Myth: the comet's tail indicates it is moving unusually fast or has hidden energy sources. Science: the tail is created by solar radiation and solar wind pushing gas and dust away from the nucleus, a completely natural process observed in comets for centuries. Myth: this is a once-in-a-lifetime event that defies known physics. Science: while SWAN's orbital period is uncertain, 1,400 to 22,000 years, comets with long orbits are normal in our solar system. Its behavior aligns perfectly with known cometary physics. In summary, Comet C/2025 R2 SWAN is a rare and spectacular visitor. On our U.S. roadmap analogy, its closest approach would be near Harrisburg, Pennsylvania, but in reality, it will remain safely millions of kilometers away. Its unexpected brightness, late discovery, spectacular tail, and uncertain orbit make it a focus of scientific study and public fascination. Made of ice, dust, and ancient materials, it glows naturally due to sunlight reflecting off dust and fluorescence from gases, creating a stunning visual display. While meteors from its orbital debris may provide a brief light show, the comet itself is harmless, a natural reminder of the dynamism and beauty of our solar system. Myths about alien machines or armored hulls are entirely unfounded. The real story, a glowing traveler from the edge of the solar system, is far more amazing than any fiction. From both a scientific and cultural perspective, Comet SWAN offers a cosmic event that combines wonder, learning, and a tangible connection to the universe, reminding us that our place in the cosmos is part of a vast, intricate system where even a single icy traveler can spark imagination and awe. This audio file and content were produced using Polyspeaks4U, South Africa's leading disability software designed for dyslexic, visually impaired, and mobility impaired individuals. Polyspeaks4U is software created by people with disabilities, for people with disabilities, providing tools that empower users and enhance accessibility.